Good afternoon. My name is Chuck Cartledge. I am going to be presenting a short demonstration of my PhD dissertation on Unsupervised Small-World, specifically a framework for web object self-preservation. During this presentation, we're going to talk about what a USW system is, in that it is at the nexus of multiple disciplines, specifically emergent behavior, preservation, and graph theory, where emergent behavior is a movement of the inanimate, preservation is ensuring that digital information of continuing value remains accessible and usable, and graph theory is mathematical structures used to model pairwise relations between objects. Lots and lots of words there. The body of that explanation and details are given in the dissertation. For this demonstration, we are going to look at a very small part of the dissertation. Specifically, we are going to have a demonstration of a reference implementation. We're going to select a web object, specifically from Flickr. We're going to create that into a component of the USW graph. We're going to add that to the graph. The USW graph was created from pages copied from Flickr, archive.org, radiolab.org, and Gutenberg, and they were all instrumented to become web objects. Part of the long-term preservation web objects, they have to make copies. We'll demonstrate that. We'll demonstrate when a copy is detecting that a copy is lost and making a replacement copy. And this is how we will do that. This is a template or plotting area for a USW graph. This area right in through here. This is where the web objects from Flickr, Radiolab, Gutenberg, and archive.org will be plotted. The relationships, the links between each of those web objects, as in a graph, will be drawn as straight lines. Things to watch for on this template are time in this area, messages that are exchanged, which will be enumerated or listed in this area, and an event counter, which will be here. The system also supports the playing of pre-recorded files down in this area. When that happens, then the VCR controls in this area become meaningful. This area is reserved for the plotting of clustering coefficients and average path lengths that are meaningful as the USW graph is created. The data that we are going to be playing with today does not populate this area. So this preserve me visualization area is the template. We have a pre-recorded template already staged right here. Each of these are web objects. These lines are links between web objects. The particulars of this web object appear down here, and a link to that web object appears here. There are approximately 100 of archive.org web objects here. There are approximately 100 Flickr web objects here. There are approximately 180 radiolab.org objects here. There is a single Gutenberg object here. These three are generalized services. One is a mailbox, one is an edit service, and one is a copy service. They are here, and they are services that are used by all of the web objects. So the USW graph is in place. It has been created. We are now going to select a web page from Flickr and add it to the USW graph. This is a web object that this is the web page we are interested in. We will copy its address. We will provide it to a custom service It is now being instrumented with USW code to become a web object. It is now ready. This is a directory listing of all of the Flickr.com web pages that have been instrumented to become web objects. We have a specific Explorer PHP file here that shows now that our particular image has been added to the Flickr CSODU edu domain. We will now take a look at that. Here is the web object itself, and here is a Preserve Me button that will will do the heavy lifting of creating and adding the web object to the USW graph. Web object exists, but it is not part of the graph as of yet. So we will now close this graph out because it is no longer, we'll close this page out because it is no longer of interest. Put this right here for just a second. Come back to the canvas. And again, this is where things will happen. In particular, after I push this button, this web object will appear in this general area of the graph, and it will appear after this timer shows it has been waiting for approximately 3 seconds. So we'll go ahead and connect it to the network, connect it to the USW graph. We are looking for activity here. Right now the visualizer is waiting. It is now doing things. These are the messages that are being exchanged. Our object has appeared here. You can see that it is talking to the mailbox, talking to the edit service, talking to different components. Now it appears to have finished its work. We're going to reload the page. The web object recognizes that it is now a member of the USW graph and that it does not have enough copies. So it needs to make more preservation copies of itself. In doing so, it will try to make a copy on the archive domain, the Gutenberg domain, and the Radiolab domain. While we've been talking here, activity has been happening over here, messages have been sent back and forth, so this is becoming more connected. We'll put it over here so we can watch multiple things at the same time. So we're going to first go to the archive web object. I'm going to click on it, and it will be doing things to the system, as in checking its mailbox, making links as appropriate. The activity here and here are the result of this web object coming to life. P edges or V edges have specific meaning. A P edge is a permanent edge. A V edge is a volatile edge. Looks like this web object has finished its work, and it has made some connections here in case you missed those. So now we will close this one out. We will now go to the Gutenberg, do the same type of thing. Have it check its health, which time it will go off to the its mailbox, read messages, perform actions, and make updates and changes not only to the USW graph but to itself. Again, V edges are volatile, P edges are permanent, and if you can see back in here, these new edges are coming into play, meaning that copies are being created off in different places. Close this out. Go to Radiolab and check its health. Preserve me viz messages will be sent to different web objects that this web object is connected to. In addition, messages are sent to preserve me viz, and new links, new changes to the graph are being created. We're adding friends and so on. Now preserve me is waiting, so we can close this out. So this web object has been sitting here very patiently waiting for things to settle out. So we're going to reload it. It says that it has 0 copies. We are going to have it check its health. And then it is going off and looking and getting information. Family messages, locations, all sorts of things are happening internal to that particular web object. It is updating its persistent memory, its persistent storage, so that when it is loaded at a later time, it will be remembered. I'm going to reload this one. And we now see that it has 3 preservation copies. The copies are on Archive, Gutenberg, and Radiolab domains. These are their full names. And we're going to go see those on the Gutenberg domain. We're going to come here to the Explorer where we started first. This is our original web object. We are going to now go to the Gutenberg domain. We are going to see the web object down here. And if we were to go to the Radiolab and go down to where where non-Radiolab copies are maintained, we would see it here. So this web object has made connections to the friend connections to Archive domain, Gutenberg domain, and Radiolab domain, and it has spread preservation copies across Gutenberg, Archive, and preservation Radiolab. Next part of the test is to destroy that. We are going to cause the original web object to be destroyed. This is analogous to the web object being deleted off of a file system. We'll wait for about 4 seconds for the message to be received, and now it no longer exists. Close this out. If we go to the Flickr domain where it originated from, it is no longer there. If we go to, don't do that, that's pulling the wrong button, restarting another instance. If we go to the Gutenberg domain, we come down to this copy of the original web object. We bring it up in a new window. The banner down here says that this is a copy and that the original is missing. We pull up its Preserve Me, and it sees that it has only 1 copy. We'll now go to the visualizer, have our page come up because we want to watch the timer here. So we have it check its health. It will go out and start looking at the domain, at its mailbox. It will start processing messages. That's the activity that is occurring here in terms of time. Here are the messages that are actually being serviced, and it is now up to date. Because the original web object was deleted, that is this red slash right here, and because we went to this web object and had it go and look at the family the USW family, we will now find that it has run maintenance, it has created additional copies. And it needs to make a third copy. So it will try and make a third copy back on Flickr. Flickr is where the original web object was created. It was since removed. The new replacement active maintainer knows about the Flickr domain, knows that it does not have a copy of itself on the Flickr domain, so it will go and attempt to make another copy on the Flickr domain. So now we go and reload ourselves. And that attempt was unsuccessful. We will attempt it again. It is going to the Flickr domain and attempting to make a copy on the Flickr domain. Check its health. Watch for time to go by here. There are many different processes, machines, servers, network communications involved in updating, maintaining the USW system. And sometimes things don't work as smoothly as we would like. But that is the way life is in the HTTP, HTML world. Things do not always work as smoothly as we would like, and so we have to be robust and resilient enough to continue operations when things aren't working smoothly. Time is going by, messages are being processed. This time is actually clock time from when the system was initiated. That's what the time is. It will retry in that number of seconds. It looks like things have settled out. So we'll close this, come back to our active maintainer, have it reload itself. Have it check its mailbox, make sure everything is okay. And continue working. And now things are happening. Family messages, locations, and so on have been received. We'll reload. Have it build its internal memory, and now it has 3 copies. So we selected a web object to be preserved. We added that web page to be preserved. We created a web object from that page. We added the web object to an existing graph. We created preservation copies of that original. We detected that a copy was lost. We then created a replacement copy. USW contributions, my PhD contributions, deal with emergent behavior, preservation, and graph theory. Within emergent behavior, we have developed techniques to mimic human and natural activities in the creation of small world graphs, and we have done this independently of any central control. For preservation, we have developed techniques to help ensure that digital data will be available long after the institutions and people who created that digital data are gone. In the world of graph theory, we have developed techniques to incrementally incrementally create small world graphs Small world in the sense of Watson, Strogatz, and Stanley Milgram. Small world graphs for the preservation of long-term data. Thank you very much for your time, and I hope you have a good day.